To calculate how many times a brown dwarf star with a 3,600-year orbit would have passed through the inner solar system over the course of 1,000,000 years. Timespan. We have a total timespan of 1,000,000 years. Orbital period of the brown dwarf. The brown dwarf has a 3,600-year orbital period around the Sun. Calculation. Divide the total time span by the orbital period to find how many complete orbits the brown dwarf would have made in that time. 1,000,000 divided by 3,600 equals 277.77 times. So the brown dwarf would have passed through the inner solar system approximately 278 times in 1,000,000 years. Gravitational disturbances. A brown dwarf is a massive object, though not as large as a star, but its gravitational influence would still be substantial. As it passed through the inner solar system, it would disrupt the orbits of planets, asteroids, and comets. Over 277 passages, we would expect shifts in the orbits of Earth and other planets, leading to long-term orbital instabilities. Such disturbances could cause Earth's orbit to deviate, potentially leading to drastic climate shifts or changes in the length of a year. Asteroid belt disturbances. A brown dwarf could destabilize parts of the asteroid belt, sending a significant number of asteroids toward the inner solar system. This would cause an increase in asteroid impacts on Earth, potentially resulting in craters, mass extinctions, and geologic layers associated with these impacts. Oort cloud and Kuiper belt objects. The outer solar system would also be disrupted, with a brown dwarf likely causing long-period comets to be redirected toward the Sun. This could lead to cometary bombardments on Earth, leaving traces of their impact in the form of craters and debris. Geological evidence. Each time the brown dwarf passed close to Earth, we would expect to see evidence of environmental catastrophes, such as crater layers. Large impacts would leave distinct craters and geological layers rich in iridium, an element often associated with extraterrestrial impacts, much like the layer found in the Cretaceous-Paleogene boundary, which marks the mass extinction event 66 million years ago. Mass extinction events. If this scenario were true, there should be evidence of multiple mass extinction events. These events would be scattered throughout Earth's fossil record, but with a regular periodicity linked to the 3,600-year cycle. We currently observe mass extinctions, but not with this regular interval. Orbital shifts and eccentricities. Repeated gravitational encounters with a brown dwarf would cause anomalies in the orbits of planets. For instance, the eccentricities, or how elliptical the orbits are of planets, would increase over time. For example, Earth's orbit, which is nearly circular, could become more elliptical, leading to extreme variations in climate, like hotter summers and colder winters. We would also expect planetary axis tilts to be significantly affected. Over hundreds of passages, these changes would create dramatic climate swings or even complete shifts in Earth's climate systems. Human civilizations have kept astronomical records for thousands of years. If a brown dwarf had been passing through the inner solar system every 3,600 years, ancient cultures likely would have documented such an event due to its proximity to Earth. But no records of such phenomena exist. While ancient texts sometimes refer to celestial phenomena, such as comets or solar eclipses, there is no consistent record across cultures of a brown dwarf-like object appearing regularly. If this had occurred, Earth's geological and environmental history would show systematic, periodic destruction and recovery cycles. However, current data shows that while impact events like the Chicxulub impact 66 million years ago caused mass extinctions, these events do not occur on a regular 3,600-year interval. Fossil records indicate long periods of stability between catastrophic events, with no evidence of regular, large-scale disruptions. Astronomical models of our solar system's stability do not support the regular intrusion of a massive body like a brown dwarf. If such a body existed, its gravitational influence would have destabilized the solar system long ago. Orbital mechanics of planets are very finely balanced. A large object's repeated passage would likely have ejected or destabilized planets, yet our solar system remains stable. If a brown dwarf had passed through our inner solar system 277 times in the past 1,000,000 years, we would expect to see significant and recurring damage, including altered planetary orbits, an increase in impact craters, mass extinction events, and disruptions to Earth's climate and axis tilt. However, No such evidence exists, leading to the conclusion that such an event has not occurred in our planet's history. Where's Nibiru at Nibiru Hunter 2024? Why there's no Nibiru at Haidito Bethion Ito Teletoyu.